Hello, and today's purpose of the day is I can find the probability of non-mutually exclusive events. To find the probability of non-mutually exclusive events, we want to figure out the probability of A or B occurring, which is equal to the probability of event A plus the probability of event B minus the probability that A and B both occurred. So again, or means we are going to add, and non-mutually exclusive means that two events could happen at the same time. So let's take a look at our example. And there's also a Venn diagram over at the right to show that if you have event A and event B, that they could overlap and it could actually happen at the same time. All right, the first example, there are 50 vehicles in the parking lot. 20 silver minivans, 10 blue minivans, 12 silver cars, and 8 blue cars. We need to find the probability of the following events. Let's first take a look at what a Venn diagram of this would look like. So I'm going to draw one below. So I've started to make the Venn diagram over at the right. Now, if I read above, I have 50 total vehicles in the parking lot. So when I'm done, all of the numbers in this Venn diagram should add up to be 50. There are 20 silver minivans. So 20 is what they both have in common. So 20 will go in the middle. Now I have 10 blue minivans. So I have 10 minivans. And I have 12 silver cars. So 12 silvers, and 8 blue cars. Well, I didn't make a circle for blue or for cars, so I'm going to put that outside of the two circles in this Venn diagram. So again, let's recap. 50 total vehicles. 20 plus 10 plus 12 plus 8 does equal 50, so that's good to check. Then to look again, we have 20 silver minivans, so silver and minivan are both circles, so 20 would go in the middle, because that would mean both silver and minivan. 10 blue minivans, so 10 is going to go by the minivan column. Doesn't matter that they're blue, they're a minivan. And 12 silver cars. Doesn't matter that they're a car, it matters that they're silver. So 12 goes in the silver circle. And then 8 blue cars, and we didn't take into account another circle with blue, so we put that outside of the Venn diagram. Now let's look at the first question. Probability that we have a silver vehicle. So the probability of having a silver would be, we have 12 here in the circle and 20, and 12 plus 20 is 32 out of 50, which simplifies to 16 over 25. And again, as a probability, we want a percentage, which would be 64%. All right, let's take a look at the probability of having a minivan. Well, we have 10 here in the minivan column and also 20 in the both silver and minivan. So 20 plus 10 is 30 out of our 50 vehicles, which simplifies to 3/5, which as a percentage is 60%. The probability that we have silver and a minivan. So silver and a minivan would only be the number that's in both of the circles, which would be the 20. So 20 out of 50, which is also 2/5, which as a probability would be 40%. And last, the probability that we have silver and a minivan, silver or a minivan, and again, or means to add. So again, silver was right up here. That was 32 out of 50 before we simplify. Plus the probability that we have a minivan, which was right here, which was 30 out of 50, minus, this comes from the formula right up here, the probability of them both occurring at the same time, which was right here in that formula, which again was 20 out of 50. So if we take 32 plus 30, subtract 20, we get 42 out of 50, which is 84%, which makes sense because probability of getting silver or a minivan, that's a high percentage there. Let's take a look at another example. Of 240 girls, 176 are on the honor roll, 48 play sports, and 36 are on the honor roll and play sports. What is the probability that a randomly selected student plays sports or is on the honor roll? So let's figure out here some probabilities before we figure out, obviously, the total that they do sports or they do the honor roll. So let's figure out the probability of girls in sports. We have 240 total girls and 48 play sports. So this would be 48 out of 240. Now the probability that they're on the honor roll, call HR, would be 176 out of 240. And the probability that they could play sports and be on the honor roll, so probability of sports and honor roll, would be, they told us 36 out of 240. So now to figure out if they play sports or on the honor roll, now we have to use that formula for non-mutually exclusive events. So the probability of sports or honor roll would be the probability that they play sports, which would be 48 out of 240, plus the probability that they are on the honor roll, which would be 176 out of 240, subtracting the probability that they do both. So sports and honor roll, so minus 36 over 240, which comes out to be 188 over 240, which is 78.3%. Now, if you also want to see what a Venn diagram of that would look like, I will draw that below. So if it helps to look at a Venn diagram, again, 48 of the girls play sports. So if we know that already 36 here are play sports and are on the honor roll, 48 minus 36 means only just 12 girls just play sports. Out of the 176 that are on the honor roll, if we know already 36 are playing sports and on the honor roll, that we have 176 minus 36 to give us 140 girls that are just on the honor roll. And if we add up 12 plus 36 plus 140, out of 240, that means we still have an additional 52 spots left, so that goes outside of the two circles of the Venn diagram. So now to answer the question with the Venn diagram, we could add up 12 plus 36 plus 140 and get 188 out of 240, which would still be 78.3%. We are now going to put a pause on the non-mutually exclusive events and look at one more probability example. A combination lock requires a 3-digit code made up of the digits 0 through 9. No number can be used more than once. How many different arrangements are possible? So arrangements, if you can recall, goes with permutation, because order matters, of 10 numbers. And why is it 10? Well, because 0 is included as a digit, so if you have 1 through 9, that's 9 digits, plus 0 is the 10th digit, and you're selecting 3, and you can't use a number more than once, that's why order matters. So permutation of 10 choose 3 is 720 arrangements. Question 2, what is the probability that all of the digits are odd? Well, first let's look at how many odd numbers are there. 1, 3, 5, 7, 9, which would be 5. So now if we look at how many arrangements of odd numbers are there, we need to figure out our desired outcomes on the numerator versus our total outcomes in the denominator. And we know our total outcomes in the denominator is that probability of 10 choose 3, which we got to be 720 from question 1. But now in the numerator, we want only odd numbers, and order will matter again. They don't want to use a number more than once. So the probability of, with our 5 numbers, we are choosing only 3. And that, the permutation, of 5 choose 3 is 60. So 60 over 720 is 1/12, which is 8.3%. So a very low percentage. But I just wanted you to take a peek at a probability example again, because you will see those soon. Thanks for listening. Please check Schoology for more information. Have a great day. Bye.